Welcome to a fascinating journey into the heart of the Great Pyramid of Giza, where we explore the mysteries of the King's Chamber and the enigmatic stone sarcophagus it houses. In this video, we delve deep into the ancient past and unravel the secrets of this awe-inspiring structure. The King's Chamber has long been a subject of wonder and intrigue due to its obscure origins and purpose. As we venture deeper into the chamber, we uncover various aspects of the stone sarcophagus, including its dimensions, structure, and the numerous theories that surround it. One of the primary points of interest is the precision and craftsmanship evident in the sarcophagus, despite the significant variations in its measurements. We examine the theories presented by renowned archaeologists and researchers in an attempt to decode its intended purpose and significance. The presence of security pins, inscribed lines, and the marks of tube drilling on the sarcophagus hint at its functional use and the techniques employed in its construction. We also explore the possible reasons for the peculiar electrical stone located beneath the sarcophagus. Throughout our journey, we ponder questions related to the builder's intentions, the purpose of the sarcophagus, and the methods employed in its creation. While the answers remain shrouded in mystery, the curiosity surrounding the King's Chamber and the stone sarcophagus only deepens our appreciation for the incredible achievements of ancient Egypt. The King's Chamber in the pyramid is constructed entirely from granite, which presents a formidable challenge to potential robbers. Even if someone attempted to tunnel around the protective portcullis chamber, they would still encounter substantial blocks of granite forming the chamber's walls, ceiling, and floor. This chamber is a spacious rectangle, measuring approximately 10 cubits in width and 20 cubits in length. The walls are made up of 5 courses of granite, each of the same height. As mentioned earlier, the thick granite flooring was placed between the walls in a way that its upper surface is at a higher level than the granite base of the walls. This design creates 2 distinct heights for those studying the chamber. The first is the height of the 5 granite courses, and the second is the height from the floor, which is slightly less. Sir William Matthew Flinders Petrie estimated the mean height of the 5 courses to be around 47.045 inches, a measurement that closely aligns with the findings of Piazzi Smith. The construction of the wall blocks appears to have been carried out meticulously, with 100 such blocks believed to comprise the chamber's walls. These walls are constructed with a high degree of precision, featuring well-executed joints, although there are some instances where seismic activity or settling has caused a few joints to open. When accounting for the open joints, Petrie arrived at the most accurate estimation of the cubit's length based on the chamber's dimensions, which he calculated as 20.632 inches, with a small margin of error, plus 0.004 inches. If we accept a cubit length of 20.63 inches, then the height of each course of the chamber equates to 2 cubits, 2 palms, or 64 digits, which amounts to 47.15 inches. Using 63 digits would result in a height of 46.42 inches. This information suggests that the combined height of the 5 courses of the chamber was 320 digits. Since the chamber is 20 cubits long, which amounts to 560 digits, it can be deduced that the total perimeter of the longer wall in the chamber is 1760 digits. Remarkably, this number aligns with the perimeter of the pyramid's base, which is 1760 cubits. Furthermore, when we divide the perimeter of the longer wall by the chamber's width, which is 280 digits, corresponding to the pyramid's height of 280 cubits, we arrive at the same ratio of 22/7 that is evident on the exterior of the pyramid. Sir William Matthew Flinders Petrie made comments about the various theories related to the pyramid, including those concerning the King's Chamber. The second height of the chamber, which is measured from the top of the floor, has led to the development of several theories, some of which are discussed in Petrie's work in the section titled, Theories Compared with Facts. Petrie suggested that the simplest theory was that the floor was raised by 1/4 of a cubit above the base of the walls. This might have been done to achieve integral measurements for the chamber's dimensions, with the squares of the diagonals resulting in whole numbers. However, due to the irregular level of the floor, different theories have emerged regarding its placement. One theory proposes a 2-cubit height, which would position the floor 2 palms above the base, equivalent to 1 digit more than 1/4 of a cubit. Assuming a cubit length of 20.63 inches, this would result in floor heights of either 5.16 or 5.89 inches, and the floor level below the first course joint would be either 41.99 or 41.26 inches. Both of these possibilities fall within the variable range of the floor's height. This complexity underscores the challenge of determining the architect's original intentions. Some authors are very confident in their theories, often providing precise measurements to many decimal places. However, great caution is necessary, especially when dealing with dimensions that exhibit significant variations. When one first enters the chamber, the most noticeable feature that immediately catches the eye is the extensive damage in the vicinity of the opening of the southern shaft. When observing the east wall of the chamber, with the entrance located in the northeast corner, the shadows in the image offer a clearer view of the extent of the damage. The identity of the individuals or forces responsible for causing this damage remains unknown, as it is a historical mystery. Nevertheless, this damage represents the most severe and destructive blemish to have marred this chamber. When examining the western end of the chamber, we can observe the damaged sarcophagus. Although we are uncertain about its original placement within the chamber, if we consider the passage axis system to be located 14 cubits east of the north-south axis of the pyramids, then the last quarter of the chamber, 5 cubits, would be positioned to the west. It is possible that the king's burial took place in this western section. We can clearly see the 5 courses of granite blocks, and it's worth noting that the top course is comprised of a single granite block. Large blocks are also present on top of the other walls. The granite flooring appears to be in good condition, but during Professor Greaves' visit, he reported the removal of a large stone next to the sarcophagus, along with an excavation beneath it. Additionally, he observed damage to the southern shaft, describing it as somewhat larger and rounder than the north shaft. As we examine the block layout on the floor, we can see some relatively large stones, and just to the north of the coffer, sarcophagus, there are 3 stones that appear to have been removed. It seems that the excavation, as noted by Greaves, has been expanded by Weiss in this area. Unfortunately, the thickness of the floor stones is not documented, but suggested a thickness of 2 cubits. Above the doorway, we can observe a substantial lintel that spans 2 courses, as reported by Petrie. He noted a remarkable diagonal drafted line on the immense granite block over the doorway. This line does not seem to extend entirely to the lower corner on the east side, but this is likely due to the block being integrated into the east wall, thereby truncating the end of the diagonal line. Petrie also reported around 15 traces of bosses on the lowest course that had not been completely smoothed away. The chamber is supported by 9 large granite beams, and as shown in here, nearly all of these beams have developed cracks on the south side of the chamber. Petrie reported that these openings or cracks are just mild signs of the extensive damage suffered by the entire chamber, most likely due to an earthquake. During the earthquake, every roof beam in the chamber was fractured near the south side. Since then, the entire granite ceiling, weighing around 400 tons, has been supported solely by being wedged and pressed into place. The damage isn't limited to the chamber alone. In every space above it, the massive roof beams are either cracked or partially pulled out of the wall, particularly on the south side. Additionally, the large eastern and western walls made of limestone, on which the construction chambers rely, have subsided. Although these movements are relatively small, typically just an inch or 2, they have been sufficient to compromise the theoretical strength and stability of these chambers. This makes their eventual collapse merely a matter of time and further seismic activity. There are noticeable stains on the ceiling stones, which can also be seen on the north side. Lehner and Hawass commented on these stains, suggesting they may be related to structural difficulties. These dark rectangular patches on the underside of the granite ceiling beams, measuring about 30 centimeters, 12 inches, wide and extending approximately a meter, 3 feet, from the junction of the ceiling beams with the long sides of the chamber, seem to be stains resulting from some structural elements. One interpretation is that these stains were left behind by the resinous tops of wooden upright posts or struts set up to prevent the massive granite beams from collapsing, possibly after the cracks had appeared and around the same time as the repair attempts noted by Petrie. It is challenging, if not impossible, to introduce such long wooden posts through the antechamber, so if these patches indicate wooden supports, they were likely installed as the granite beams were being laid in place, before the chamber was entirely roofed. Lehner and Hawass also mentioned other suggestions made by some authors, proposing that an internal framework might have been installed to create a shrine within the chamber. However, this theory has some challenges, such as the frame's size and the question of why the granite walls were finally finished, especially considering that they might have been covered by a shrine. It's possible that the walls were initially assembled with excess material on the face to protect them, with final dressing occurring after the walls were constructed. This dressing might have taken place from the top down, which could explain the traces of bosses on the lowest course. Consequently, a significant amount of work was still required inside the chamber after the ceiling slabs were placed. Inside the chamber, if the wooden beams couldn't be passed through the antechamber, there might have been a considerable pile of timber, along with the sarcophagus. The beams with the dimensions described by Lenner and Hawass through the antechamber. They utilized a height of 230 inches, 5.84 meters, for the chamber measured from the floor. Although the chamber's width is only 5.24 meters, which is half a meter less than the beams, the passage itself is over a meter wide. In a computer-aided design (CAD) model, it found quite straightforward to introduce the beam with ample room to spare. If the beams were to be installed beneath each roof stone, the result would be similar to this view. However, the issue in introducing the beams was at the junction of the ascending and descending passages. At this point, it would unable to maneuver the beams through this junction, as it would require significant ceiling chamfering, and the loss of any covering stone. If these beams were indeed brought in to reinforce the ceiling, the most plausible scenario would be that they were introduced through the robber's tunnel, commonly referred to as Mammon's Tunnel, as discussed in Part 1. It's worth noting that the data about this tunnel is not ideal, and it's possible that it underwent some enlargement at a later time. This, in turn, might suggest that any efforts to shore up the ceiling were part of a restoration project. The robber's tunnel, also known as Mammon's Tunnel, could have been created by the original trespassers or violators of the pyramid. The plastering applied to some of these cracks, as reported by Petrie, was likely purely cosmetic and may not necessarily date back to the time of Khufu. In other words, it might have been added during a later phase of repair or restoration. The tunnel that extends from the top of the Grand Gallery to Davison's chamber is often suggested to have been created by the pyramid builders to inspect the extent of damage in the chamber above. However, it raises the question of whether the masons would have actually undertaken such an action. The presence of cracks in the ceiling beams would have provided them with all the information they needed to assess the condition. Creating a tunnel through the masonry to investigate would risk undermining the structural integrity of the chamber further. Moreover, it's unlikely that any repairs could have been carried out in the chamber. If these beams indeed cracked during Khufu's time, it's plausible that a significant portion of the pyramid had already been completed above, exerting stress on the beams. Correcting this issue would have required dismantling a substantial part of the pyramid. Alternatively, they could have opted to support the roof, and if the beams were too long to pass through the junction of the ascending and descending passages, they could have been brought up in smaller sections. It's suggested that this damage could have occurred during the construction of the pyramid. However, we can't ascertain this with absolute certainty. The tunnel, as depicted in Paring's drawing, could equally have been a searcher's tunnel, created by someone curious about what lay above the king's chamber ceiling. Egypt has a long history of earthquakes, and it's impossible to determine how frequently the structure may have been affected by such events or when these beams cracked with complete certainty. It's also plausible that the cracks are a result of settlement and unrelated to seismic activity. The sarcophagus. The badly damaged granite box mentioned above has for some reason piqued the interest of many theorists. A quick look at the tables of dimensions by Piazzi Smith and Petrie reveals that they both dedicated a significant amount of effort to measuring this box. Even the brief account by Professor Greaves provides detailed measurements of it. Petrie described the box as follows. The coffer in the king's chamber is of the usual form of the earliest Egyptian sarcophagi, an approximately flat-sided box made of red granite. It features the typical undercut groove designed to secure the edge of a lid along the inside of the north, east, and south sides. The west side is cut away as low as the groove, allowing the lid to slide over it, and it has 3 pinholes cut into it. These holes are intended for the pins to fall into, aligning with similar holes in the lid when the lid is placed on the coffer. It's worth noting that the coffer is not finely crafted and cannot, in this respect, compare to the coffer in the second pyramid. In essence, the coffer in the king's chamber is a red granite box with a design typical of early Egyptian sarcophagi, featuring distinct features such as the undercut groove and pinholes for lid placement. However, it falls short of the fine craftsmanship seen in the coffer in the second pyramid. Smith only provided the mean thickness of the 4 vertical sides, which was 5.99 inches. All measurements are in inches. This image provided by Piazzi Smith. We can see some of the equipment he used to measure the box. While the mean measurements previously may differ slightly, it doesn't necessarily indicate that one scholar is more correct than the other. The approaches to measurement can vary between the two, and it's important to note that these are mean measurements, with individual values often deviating from the mean. For example, Petrie highlights the variation in length on one side of the box, noting that the measure at a specific point differs from the mean value. These fluctuating measures provide ample room for theorists to propose various design intents. As Petrie suggests, the theories regarding the coffer are extensive and often have discrepancies due to the irregularities in the coffer's craftsmanship. One noticeable observation from the works of Smith and Petrie is that the east side of the box appears to have the finest plane, with minimal errors. This might be attributed to a common engineering practice where a master side is created first, ensuring it is very flat and accurate, and subsequent measures for other sides are referenced to this master side. A similar process could have been employed in the creation of the sarcophagus. In an experiment to convert the measurements into Egyptian digits, based on a cubit of 20.63 inches and not going lower than 1/3 of a digit, the following suggestions are made. External length 122 digits, height 56 digits, and width 52 1/3 digits. The side thickness is at 8 digits, and the thicker bottom is at 9 1/3 digits. The box's height appears to be intended as 2 cubits high, but the missing lid raises questions. If the floor was meant to be 2 cubits below the first course joint, the box would be level with this, and any lid would be above it. The wall course height of 64 digits seems significant to the chamber's design, and if this was intended to be the intended height of the complete sarcophagus, then the lid would be 8 digits high, 2 palms, the same thickness as the sides of the box. The lid, in this configuration, would be 1/7 of the volume of the solid box, and it might have been intended that the thicker base of the box was 1/6 the volume of the solid box. This could explain the apparent thinness of the lid compared to Khafre's sarcophagus. Ultimately, the variable dimensions of this box allow for a wide range of theories, and while one can manipulate figures to support various ideas, the great variability in measures practically accommodates any theory. On the western edge of the sarcophagus, 3 holes were made to receive security pins. These pins would fall down from the lid when it was slid along the grooves cut into the top of the box. This design was intended to prevent robbers from sliding the lid back. A similar method was used in Khafre's better-preserved sarcophagus, but it had only 2 holes. Petrie reported the presence of many saw lines visible on the exterior of the box and tube drill marks in the interior, which were used in the hollowing out of the box. Petrie also found a large flint pebble under the sarcophagus, which he considered important. He believed that the presence of this pebble suggested that the sarcophagus was first lifted at a time when no breakages had occurred in the pyramid, and there were no stone chips lying around. This, in turn, suggested that there was some means of access to the upper chambers that was always available by removing loose blocks without the need for any forced entry. If the stones at the top of the shaft leading from the subterranean part to the gallery had been cemented in place, they would have had to be broken through. If there were granite portcullises in the antechamber, they would have been destroyed. It seemed unlikely that anyone would go to the trouble of fetching a large flint pebble into the innermost part of the pyramid if there were stone chips lying in their path. Interestingly, this pebble was also noted by Piazzi Smith and remained in position until Petrie's time. Piazzi Smith described it as tilted up at its south end by a black flint pebble, about 1.5 inches high, pushed in underneath the southwest corner. This pebble was likely brought in by searchers who wanted to move the box by placing a round stone under one corner and pivoting the box around it. This technique can be surprisingly effective when trying to move a heavy load. The fragments of masonry, which would have been plentiful in the pyramid, were unlikely to provide a suitable stone for this purpose. Therefore, it's not surprising that a stone was brought in from outside. Piazzi Smith found another stone inside the sarcophagus. He asked what this large stone was doing there and was told by someone that travelers used it when they visited to strike the coffer, creating a bell-like sound. Piazzi Smith then asked to have the stone removed and thrown into a deep excavation under the floor. In this early image by the Edgar S., we can see a hole in the floor in the bottom right corner. There are also numerous graffiti marks visible on the walls, which have since been cleaned away. However, one piece of graffiti may still exist inside the chamber, and it's that of Petrie himself. In his journal, he described the operation of lifting the sarcophagus to measure its bottom. After completing this task, he mentioned, "Then we lowered the coffer again onto its stone, first cleaning out everything but fine dust from under it. The only time I ever did such a thing. I chalked on the bottom of the coffer, lifted the 9th of April 1882 WMF Petrie, with Ellis putting his name and date on the floor underneath it." In conclusion, we hope that this journey into the heart of the Great Pyramid of Giza has been enjoyable and enlightening for you. In this video, we delved deep into the secrets of the King's Chamber and the stone sarcophagus, providing you with a comprehensive look at the history, engineering, and mysteries surrounding this magnificent structure. The Great Pyramid of Giza remains a testament to the ancient Egyptian civilization and its remarkable achievements. It always reminds us of the extent of human ability to build, create, and leave a historical footprint that spans thousands of years. We always encourage you to continue researching and exploring, whether in the world of archaeology or in any other field that piques your interest. Understanding and appreciating our history enriches our perception of the world around us. Thank you for joining us on this journey, and we look forward to seeing you in our upcoming videos on our channel. Don't forget to subscribe and hit the notification bell to stay updated with our latest content. Once again, thank you, and we wish you happy days filled with discoveries.